Okay, so today we are going to be doing the next chapter, which is part of the new quarter, quarter 4. You see the purple one there called Unit 13, Linear Programming. That's where you need to go within our Schoology course. So inside Linear Programming, you will find, of course, a whole bunch of days. We are doing day 1, so click there. And then within this, I'm going to be opening the one for the teacher called Dot Notebook. You're going to be opening up the top, the first one that says Notes, which is this one right here. So if you would open that one for Lesson 1 and 2, Linear Programming Notes, that would be awesome. I am going to open up the teacher version of that. And I'll pause for a second while I get that open. Okay, this is called Linear Programming. And that sounds complicated because this is the programming part. But by the end of this time, just today, you're going to understand the idea of just graphing linear inequalities. Basically, that means you're graphing lines, except you're shading. Do you remember doing the ones where you graph the line, but then you shade on one side of it? That's pretty much all we're doing today, except maybe a little bit of writing equations for situations. So if I said I'm charging $25 per hour plus $10 to start. That is an equation. And then if I say I'm charging more than that, all of a sudden I just turned it into a shaded above the line kind of equation. Okay, so that's the main idea of where we're going with this. I want to just kind of give you a big picture of where we're kind of leading to, because the research shows that if you know kind of where we're headed, that you will understand it better in that context. All right, so when we're done, you'll have like graphed a line like this and then shaded below it. And then maybe it had a dotted line that went like this, except I'll make it dotted. Whoa, hit the wrong button, backing up a notch, sorry. So I'm going to get rid of this guy and make it a dotted green line. What does that mean, by the way, if it's a dotted line? Things that are on the line, do they actually work or not? They don't. That's what a dotted line means. That's like a border line. And then if I shade up from there, then that means that the things that are above that line work, but the line itself doesn't work. Okay? And then there's something called a common sense equation, and that's that, that's the line for 0, and let's say it's time. Do you get time can't be negative, and therefore I could draw a line this way and say you need to stay on this side? Because if time is going on, it's going that way, and time would start at 0. And so that's just called a common sense constraint. So once you graph all these things, do you get that some of them are overlapping? Let's do one more line to kind of contain it all. Let's say that I said there was an equation like this that was, we were not going to go any further than 2 hours. So that's another line. Neck, it's shaded in. Also, let's say it shades this way. When you're all done, you got all these lines shading. Where they all overlap would be like in here. And that is any dot that's inside there works for all of the equations. Do you get the idea? The answers that are in the shaded region work for everything. Yes? Okay. Oh, you know what? That dotted line, you caught me. Nice catch. That dotted line one, it was supposed to be above that, so I should not have shaded above that. My bad. Good catch. Okay, so and that's just the x-axis, here's the y-axis. So there. Now that it's all shaded in, this is called the feasible region. Do you get what's inside there, with the little exception of this little line on the bottom is actually a dotted line, so the actual edge of this line doesn't work either. That feasible region, all the things in there are feasible. Do you know what feasible means? Possible, basically. Okay? So those are the things that are possible. Now, let's say that we had context for this. Let's say that the things inside there were all combinations of things that you could make. Like, let's say this is this direction, instead of being time, let's say it's CD players. Do you believe that they still make CD players? They do. Okay. And let's say that this other direction, what's another technology that's kind of dying? Yes, yes, okay, just plain old-fashioned stereo. Because nowadays, REO, because nowadays people are going with like the small little device like an iPhone and then their headphones, so they don't buy like rack stereos as much anymore. Now, still some people have them at home because they do give better sound actually than your. I know you think of your iPod, for instance, or your iPhone as having like, you know, when you listen to music that it couldn't be any better. Did you know that actually those files, those digital files, aren't as complete because they're small enough to fit through digitally, like on a phone and stuff? There actually is better sound. Like there's better music out there. There's yes, like vinyl. There is actually, you know, you can hear the same song you were listening to can sound better because it's not an MP3. Because MP3s are crunched down to be smaller and they lose some stuff. Okay, so anyway, let's say that you are selling CD players and you're selling stereos and you got this area. These are the ones that are possible combos. Like this right here, that might be a certain number of CD players and a certain number of stereos. Let's say this is like 12 CD players, and let's say it's like 10 stereos. Then this combo right here means you are making 12 comma 10, which is I'm making 12 CD players and 10 stereos, and that combo is something my factory could handle. Do you get over here, it would be like 14 CD players, and maybe you just can't make that many at one time in one day. You only have the manpower to at most make 12, and so it stays inside this little zone. So anyway, this zone again is called the what? Feasible region. And I'll tell you that usually when it's all done, we have one last piece, and that's that you got to find the ultimate combination. In a business, do you get their goal is to make a profit? They want to make money. Okay, so yes, there are other good things in businesses where they try to help people, but if they don't actually make a profit, if you start, then you'll get the opposite, which is a loss. And if you have losses year after year, you start having to lay off people, and you have to make a profit to make it all work. These corners, one of those corners is going to have the most profit. It'll be one of the vertices, corners, of the feasible region that will give you your final answer. There, I've just taught you like the big picture of what you are going to be doing for this whole unit. Now, today, all we're doing is drawing these lines and shading on one side or the other of them, and then taking situations and saying, okay, if I say I can make no more than 10 CD players, what's the equation for that? Take the words, make an equation. Take the equation, graph it, and shade. So the most complicated today you're going to get to is things like, okay, we make an equation like this and shade up, make an equation like this and shade down, and maybe make one more equation that's like this, and you shade inside, and then you go, oh, there's my feasible region. That's the only part for today. All right, so let's get to it. Everybody flip to this slide here. If I say greater than, you know that's a greater than sign. But what if I say more than? Isn't that pretty much the same thing? Yeah. Or above, that also means the same thing. So if any of these words would mean you should use that symbol. So when later we're translating and saying Bob can make no more than 12 CD players, you got to be able to translate and say Bob is like this guy, and we're going to say CD players are X, and he can make no more than. Which one of these would be no more than? A, B, C, or D? Which one of these would be no more than? No more than. I agree. That's a no more than. Okay? Not greater than would be the same as a no more than. That makes sense? Okay, so you got to be able to take words like that and say, okay, well, if Bob could make no more than, less than or equal to, 12 CD players, then my equation's like that. So you got to be able to use the right little symbol. Okay, so what if I said, I should have left those labels there. A, B, C, D. What if I said, I need to be, I'm only am allowed licensed for, this is true, I'm only licensed to teach up through 12th grade. I cannot teach at college with my Minnesota State license as it is right now. Okay, so I'm licensed K through 12. I have to teach what one of these symbols, 12. Is it A, B, C, or D? All right, it's the less than or equal to, because I could teach 12th graders, but I should probably say less than or equal to 12th grade. All right, and some people are licensed for middle school. Do you know what that license is? I think it's actually 6, 7, 8. I could be proven wrong on this, but like some of the teachers are licensed. They have what's called a middle school license, and they're allowed to teach. A lot of them are 6, and then they can also teach 7 and 8. So like they're at elementary school, but they can also teach up through the 8th grade. So what if it was that? 6 less than or equal to x less than or equal to 8. You get what I just did there? It's a sandwich. The ages they can teach are between 6 and 8. Okay? Could I break that into 2 things? Yes. Would you please write me 2 things that this is saying separately? X is this and X is that. Break that up for me. So X is this and X is that. Give me one of the 2. Raise your hand. Somebody can do this. I'm throwing you softballs right now. Yes, sir. Greater than or equal to. Notice he switched the sign because we switched them around. The 6 used to be first. Now the 6 is last, so we switched the sign around. Very nice. And the other one? Yes, sir. Less than or equal to 8. What just happened there? Why did this sign switch? Because these used to be the other way around. If they switch back and forth, the sign has to switch to match them. Okay? So X is bigger than or equal to 6, and X is less than or equal to 8. Now, let me challenge you with this. Can you make me a little sketch? You can probably slide down underneath this picture and show me where the equation X is less than or equal to 8 and X is greater than or equal to 6 would be. Some kids are going to do the lines up and down. Some are going to do the lines like left to right. You got to figure out which way is the right way to do an X equals equation. So is it like this and this? Or is it the other way? Is it like this and this? Here's where X is 6. That's a hint. Do you get if X is 6 right there, it's got to go through that spot? And also 8, which way are the lines going to have to go? Vertically or horizontally? Vertically, very nice. So they look like this. Goes through there, goes through there. They should be straight up and down. I'm slightly off. That's okay. And then do you get this one's bigger than 6, so I'm going to shade on this side of the line. I have a hint for you. It's so much easier to just shade a little bit on one side of the line. It's true, you could, if you wanted to, go like this, but your drawing is so messy, so quick. I strongly encourage you to just shade a little bit on one side of the line. Okay, next, X is less than or equal to 8. That means it has to stay on this side of the 8. Now, I'd use this special tool to draw these lines because they would be nice and straight. But what's wrong with my lines, actually? Yeah, they're slanted a smidge. Didn't mean for that. They're dotted, yes. I should have used solid lines. Why? Because when you use a dotted line, you're saying it doesn't work at 6. Does their license work at grade 6? Yes. And therefore, it should be a solid line and a solid line. And then shaded in between.
So even though it's like a small line that comes into the X is greater than or equal to 6,
Yep.
there's a chance that it could be a
Okay, I get what you're saying. You're saying that this could extend this way, right? But it can't be both. So when we do these, we want to really focus on what overlaps. I get what you're saying. If you shaded both of them forever in their directions, they'd look kind of like this. But do you get that what's overlapping is what's really important? So I think it's cleaner looking to just shade a little bit on each side than to shade forever and in both directions. Does that make sense to you?
Yeah.
All right, good. So let's get to this next thing. Here's a situation from everyday life. There are more than 10 people in line. Just use X and write me an equation. Hopefully you said X is greater than 10. Raise your hand if you had that right. Good. That was a really, really easy one. Okay. So more than, come on. That's pretty much the same thing. How about we do a graph of it? Well, if I put a 10 here, if I was going to graph this, do I use a solid circle or an empty circle? Can it be 10? So empty circle. And then you go to the right of it. That would be graphing it two-dimensionally. But that would be graphing it only with an x-axis. We're going to be graphing x and y like this. So they're going to be a little more complicated than that. We've already moved you past this. So. All right. Susan called to say that the only tickets available for the Britney Spears concert, which I know that you were looking forward to, are in row 10 or above, but less than row 40. Write me an equation. That's actually two equations. You guys can see it already? Oh, boo. Okay, did you see that then? Okay, so it's, notice we use the sandwich here. Could you write it as two separate equations? Yeah, gave you an example of that already. All right, so it's between 10 and 40. Notice the difference. Can it be 40? No. All right, so it goes like that, and notice there's an empty circle on 40 because it can't be 40. Again, these are the baby ones. You've done this way back in algebra, so we're just taking a kind of a slow, easy review. So if you have two variables, you have a y and an x, do you get normally we have it solved for y? You are going to do that again. You want to solve these for y because they just work so much nicer. Because once it's solved for y, I'm taking 4 away from both sides, everybody do this with me. Once you solve it for y, then you'll know which way to shade. If you don't solve it for y, you have to test points, which is really icky. Can I just leave this negative on the y? It'd be so much simpler if I could. No, can't. Got to get the y off there, the negative off there. So if I do that, I'm multiplying by a negative or dividing by a negative 1. Exactly. Thank you for remembering that. If I multiply by a negative 1 on both sides, then I have to flip the sign. This sign switches from a less than to a greater than. Okay, so I have y is greater than, and I'm multiplying this out, negative x plus 4. Notice I didn't just put a negative on one thing, I put a negative on both things on the right side. On the left side, the negative just canceled the other negative. It became positive y. So, moral of the story here. In inequalities, if you ever multiply or divide by a negative, you gotta switch the sign like that. Now that we've done this, this can be graphed, and then you shade. It's so simple. If it says greater, does that sound like above or below to you? Above, and it is. As long as you solve it for y, then you can just do what it sounds like. If it says greater, you go above it. If it says less, you go below it. Okay, so let's graph this line. Where is the line y equals negative x plus 4? Well, do you remember that this means that we're having a y-intercept of 4? And this means we have a slope of negative 1. That means we're going down like this. Should I use a solid line or a dotted line? Solid, because notice this is an equal to sign. If that didn't have an equal to sign, I use a dotted line. And then it seems like greater seems bigger, so you just shade above it. There we go. So moral of the story on this one, make sure you solve it for y first. Then you graph it. Then you can shade above it or below it. All right, I'm going to pause for a second. Okay, so let's move on to, already done that one, and here's all the work for it. I guess it's a little cleaner and nicer than what I did, but it's the same idea. And which way are they going to shade this one? Above it, because it says greater than. If it was a less than sign, you shade below it. All right, and let's get to this guy. Why do they have this? Is this a true statement? Does x is less than or equal to 6 mean x is 6? Is x 6, period? No. Could x be 6? Yes. So the recommendation here is that when you see this and you're graphing and you're like, how am I supposed to graph this? You graph it just like it's an equals. Because that's part of it. This is equal to or less than. So you just act like you have an equation. You're used to these. You've done these since algebra class, which is 2 classes ago. You can graph that. The y-intercept's 5, the slope is 2. No big deal. And then at the end, you just got to remember that this means shade. Okay, so what this slide is trying to point out is that you act just like it's an equal to sign when you're doing everything, but in the end, you just shade in the right direction. All right, take a look at this one. Does this, if I'm graphing x equals 6, have I started it properly? All right, and now which way should I shade if it's, how, you can't go above and below when the line's straight up and down. Do you logically know if it's a greater, or excuse me, a less than sign, which way you should go? Should I go left or right? Left. As long as you have solved it so that the variable here is on the left, and it's, if you can make it a y, that's awesome, but if there is no y, like on this one, you have an x there. As long as you've got the x on the left like this, it just logically, if it says less than, you shade less than 6, which is like 4 and 2 and negative 2, and you shade this way. That make sense? So if the line's like this, you can shade above or below it. If the line's like this, you can't shade above or below it. You have to shade right or left. So one more like that. If I said x is greater than 12, I got to find where x is 12. And then should I use a dotted or solid line? Dotted, because there's no equal to sign. There we go. There's where x is 12. Now which way should I shade? It says bigger than 12. Right. Because you can't go above or below. If it bigger than normally means above. But things that are bigger than 12 are to the right of it. Yes? Yes, if it has this part, if it has an or equal to, we would have used a solid line. Okay, so if I just make that change, then I got to make this a solid line, and I'm good. Okay, let's get to sim. Actually, I'm going to jump into this one here. Y is less than x plus 8. Okay, so where would I start this equation? What's that called? The what? Y-intercept. The y-intercept is 8. You put a dot right there. And then what's its slope? Well, it's that number that's right there, but you can't see it. 1. So it has a slope of 1. So that means rise, or it's rise over run, right? Okay. So it's rise 1, run 1. Rise 1, run 1. Rise 1, run 1. There's my line. Should it be dotted or solid? Dotted line. Okay, I'll go back and put in a few dots with my eraser here. There, dotted line. Am I done? No, what's the last part? Shade, which way? It says less than. This is a line that doesn't have a left and a right. You can't say left or right. Is it above or below? It says less than. Below. Below the line. You don't want to say to the right or to the left. Not unless it's a line that's going straight up and down like this. Like if I had a line right here, then I'd have to pick right or left. Okay? Nope. Y is less than blah, blah, blah. All right, so Y is less than. This less than sign means shaded below. All right, so if I just have a sign, does that mean below or above? Below. If the line is up and down like this, does that mean to the left or to the right of it? Less than means to the left. All right, what if it's kind of a slanty line? Then it's above or below. Which one should it be? Below. All right, I think you get the idea. All right, so this one is starting to shape up with this dotted line here, and then when they get it all put together, all of them overlapping is called the feasible region. Okay, that's what you're going to be making today, is a bunch of graphs that'll look like that when they're done. So let's get started on it together, and I'm going to pause for a second while I pull up the worksheet. I'd like you to do the same. Okay, and this is where I'm pulling the worksheet from, Lesson 1, Linear Programming, Day 1. Okay, and here we are. I feel like this worksheet is a little bit long to try to keep your assignments reasonable size. I think I am going to cut one of these out for you. This has got 3 parts. Will save you a fair amount of time. Let's skip number 3. Let's skip number 3. Okay, now let's get to number 1. Just problem 3. They don't take that long. All right, notice the nice part about these, they're all solved for X or Y. See what I mean? You don't have to even solve them. When you get to the later ones, you'll have to solve and get the X or the Y alone. But for right now, X is greater than or equal to 1. Dotted or solid line? Solid line at X is, I always start, here's where X is 1, and it helps me to see whether I should go across or up and down to put that dot in there. Because that's where X is 1. Now, it's up and down, and it's solid because it says or equal to. And now it says bigger than 1. Just think about it. Where is X's that are bigger than 1? They're like over in here. So, shading on this side of that line. Take my advice, don't shade forever, just shade a little bit on one side of the line. Now, Y is greater than X plus 1, this equation. I'm going to start by saying Y-intercept is 1, put a dot right there. And then the slope isn't there, but it's a 1. And remember that slope is rise over run. So if it's a 1 for the slope, then it's 1 rise and 1 run. Well, rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. There we go. You start catching on, and it's really quick after that. And then dotted or solid line. Solid, good. Because it has an or equal to sign. And then actually I should keep going all the way to the edges of the graph. That's a good practice. I know it's a little bit of a pain, but you really do need to know where it overlaps for this whole graph. There we go. And now I'm going to shade, it says bigger than. You should just feel natural. What's bigger than? Does that seem like above or below? Above, good. And there we go. Can you see that our feasible region is shaping up? It's probably going to be like in here. But we don't know yet until we're done with the third line. The third line says Y is less than or equal to 8. Let me get that out of there because I got to put in the third line. Here's 8. You could have started with where Y is 8, right there, and then quickly you would have figured out, oh, it must be a line this way. And then it says less than or equal to 8 underneath this line. Now I've got my little feasible region. Final deal is to actually shade in that feasible region really dark. This is the only area where you really shade it in dark. And there we go. Because when you're done, the only points that actually work are the ones that are shaded by every line. The dots that are where I shaded there, the things like in here, they are going to work for all 3 lines. Those are the only dots that work for all 3 lines. So if I pick that spot and it's at 3, 7, that's where that red dot is. 3, 7 would work in all 3 of these equations. It would be a true statement if I put it into all 3. All right, that's called finding a feasible region. This is a pretty easy day, I think you'd have to agree. That's all I got for you for today.